The overall goal of this procedure is to quantitatively assess the benefits of supported photocatalysts in environmental applications and to understand the implications of chemical bonding between catalysts and their supports on DNOx aspects of air quality management.
The greater accessible surface area offered by supported photocatalysts suggests a more efficient ability to reduce NOx concentrations in the atmosphere. However, little is known about the influence of the support on the catalyst performance and properties.
NOx mainly consists of NO and NO2. The more toxic NO2 has the largest negative impact on air quality. So, photocatalysts must exhibit really high selectivity for oxidizing NOx to nitrates.
The technicals described here provide insights which can be used in engineering effect solutions for urban air quality management, such as photocatalysts supported on the surface of concrete infrastructure.
To prepare the QT1 composite, first ball mill commercial quartz for 15 minutes. Sieve the milled quartz powder to obtain quartz particles with sizes ranging from 20 to 100 microns. Next, mix 2.6 milliliters of 97% titanium butoxide with 29.6 milliliters of absolute ethanol to produce a titanium precursor solution. Suspend 3 grams of the milled sieved quartz powder in 30 grams of the titanium precursor solution. Add to the suspension